if you have x and it's being squared, you can get rid of the squared by square rooting. So our strategy in these ones, right? And I'm gonna give this technique a name. Solve by square rooting. The name of this technique is pretty self-explanatory. You can get rid of an x squared or any squared by square rooting. How is this helpful? Well, in A, I could first move the 7 over and get the x squared by itself. Once I get the x squared by itself, I could square root both sides. And square rooting both sides, we have to remember it could be positive or negative. And so we get x is plus or minus the square root of 5. If you can get the thing that's squared by itself, you can get rid of it by square rooting. Why doesn't that work? Here, I'm going to add a question, 8.5. I don't know if 8.5 is really I needed something in between A and B. Okay? If I had 3x, or here, I'll just do an x, or something really, I have x squared by itself, and I could solve by square rooting. Why is this one a bit of a problem?
Because then we have the square root of x, then we have to square root again.
Yeah, like I could square root this side and get plus or minus, and then but unfortunately I can't get the x by itself because there's still an x on this side.
And you would need a logarithm, I think.
Yeah, you would need something else. This is not working out for us. So this idea of solving by square rooting only works if the only x you have is in something squared. If I have extra x's, like, oh no, now I've got an x inside of square root. How do you get rid of an x inside of a square root? You square both sides. And then, voila, we're back to where we started. And we could just keep going in circles over and over and over again, and this would be very problematic. You see how that is a problem? So you just keep going back and forth and you don't get anywhere. But in B, what's the difference in B? Is the x is only in the thing that is squared. So now I could square root both sides. X plus 3 equals plus or minus the square root of 20. And I could get x by itself. And then I would lose a half mark because I can simplify the 20.
The textbook also didn't simplify those.
The textbook doesn't simplify because they wanted, some people decide to teach this unit before they teach the square root unit.
It's an odd decision.
Not necessarily. So you would have to learn to simplify later after you do the square roots. But if you hadn't learned that yet, they didn't want someone to get the answer at the bottom and be like, I'm confused because I haven't done this yet. So, yeah. For example, in grade 11, I teach chapters 1 to 8 in the order that this book has, because I'm fine with the order. In grade 12, I teach chapter 3, 6, 7, 1, 5, 8, 2, no, 1, 5, 2, 8, 4. That's the order. Totally different. Because I like that order for what it makes sense for that one. So you have options in the chapters. And that's why they didn't simplify, but it is best if it is simplified. So our questions for practice for this one are just number 4.